Okay, so yesterday we learned what it means for two events to be mutually exclusive. Can I get a show of hands? Who remembers what it means to be mutually exclusive? Yes, Bree.
If one event happens,
Good, very good. They can't happen at the same time. So if A happened, I know B did not happen. There's no overlap between the events. And we gave a couple examples from decks of cards. Like if I draw a card from a deck of playing cards, it can't be both a king and a queen. It's one or the other. It'll never be both. Good. And we know that if they are mutually exclusive, to find the probability of A or B happening, we just add A or B. A plus B. Yeah. The question is what happens when the events are not mutually exclusive. So we're going to consider an example, which is, suppose we take a single six-sided die and we roll it. I am interested in rolling a prime number or an even number. To figure this out, we are going to look at the sample space. So when I roll a single six-sided die, what are my possible outcomes? Marilyn, what are my possible outcomes? I roll a six-sided die. What am I going to see? What are the possible outcomes when I roll a die? Yeah, perfect. Numbers 1 through 6. Perfect. So my sample space is 1, 2, 3, 4, 5, 6. Those are the possible numbers that I can roll when I roll my six-sided die. Good. I'm going to do this with some color coding. We'll start with prime numbers. Prime numbers are numbers that have only two factors, 1 and themselves. Which numbers up there are prime? Raise your hand if you know. Prathana. Not 1. Can you give me another one? 2, yeah. 2 is prime. 3 is prime. 5 is prime. 1 is a special case because 1 only has one factor, itself. Primes have 1 and itself. So 1 is a special case. 1 is not prime. So 3 numbers are prime. Which 3 numbers are even? 2, 4, 6. Good. 2, 4, 6. I see a problem. There is a number in there that got circled twice. Are these two events mutually exclusive? No. There is some overlap. So the question is, how do I calculate this probability? Up to now, we would do probability that it's prime plus probability that it's even. We circled 3 prime numbers out of 6. We circled 3 even numbers out of 6. Did I circle 6 numbers in total? The answer is no. There's one number up there who isn't circled. So I know that this should add up to 5 over 6. I'm making a boo-boo when I do it this way. The question is, what happened? And the answer has to do with the number 2. When I calculated P prime, 2 got counted. When I calculated P even, 2 got counted again. But 2 only appears in the number list once. I have double counted him when I did it this way. To fix the problem, I have to subtract the double count. I double counted one of my outcomes. anytime I have events that are not mutually exclusive, I can't just add. I have to subtract off the overlap because those things get counted twice, first with A and then again with B. But they don't occur twice in my sample space. I have to subtract off the double count. And that is where our general addition rule comes from. If I look at this pattern, it was PA plus PB minus P both. One number was circled twice. So on the next slide, when I write my general addition rule, PA or B is just PA plus PB minus P both. Bless you. Allergies are fun. You should start with the general rule. This is the one that's going to be on the equation sheet on AP test day. If the events are mutually exclusive, when you take a look at your sample space, you'll see that there is no overlap. This guy will naturally just be 0. So start with this guy, and then anything that's mutually exclusive, that will drop out anyway. So PA or B is A plus B minus the overlap. A plus B minus the overlap, yeah? Not so scary. We're going to do an example together, and then I'm going to have you do one. First example says, during 1 month of production by a national candy manufacturer, 35% of chocolate bars contain nuts, frowny face. 20% contained caramel, 12% contained both. If you randomly select a chocolate bar from that month's production, what is the probability that it contains nuts or caramel? So I'm going to call nuts N, caramel C. I want the probability of getting N or C. And according to my general addition rule, that should be Pn plus C minus N and C. So let's pick those out of the formula, or out of the problem. What percentage of chocolate bars for that month contain nuts? 35. So 0.35 plus what percent contained caramel? 20, 0.20 minus what percent contained both? 12, 0.12. So that would be 55 minus 12 would be 43. So 43% of chocolate bars contained nuts or caramel or both. Not too bad. Let's read the next one. Next one says, survey about social media use suggests 69% of US adults use Facebook, 40% use Instagram, 32% use both. Suppose we select a US adult at random. What's the probability that person uses Facebook or Instagram? I'll give you about 90 seconds in your small group. Find P, Facebook or Instagram. Facebook or Instagram. one there. I'll have to bring one from home tomorrow. All right, Sadie. Walk me through what we should do. Can I get a thumbs up if you agree? Good. So 77% of US adults use Facebook or Instagram. What's missing here that I had in this previous solution? Good. So there's an expectation that you're using probability notation to label your answers. Good. Very good. Not so scary? All right, so the next thing we're going to look at, last thing for this section of notes, is a tool that's going to help us with those types of problems. And that tool is a Venn diagram. Venn diagram is just a picture that organizes a sample space and shows the relationship between events in that sample space. So we're going to fill in this Venn diagram for the Facebook and Instagram example. So in this picture, the box represents the population of interest. So what population were we looking at in example 6? Bigger. US adults. Very good. So this box represents all US adults. So that box is 100% of US adults. Meaning if I add up all the areas in that box, it should add to 100%. I'm going to label those circles, F for Facebook and I for Instagram. And then I need to start filling in boxes. And I'm going to start with the easiest one to pick out of the word problem. We were told how many use both. What percentage of US adults use both Facebook and Instagram? 32. The overlap here is my 32%. That's the area in the graph that represents people who use both Facebook and Instagram, because that's where F and I overlap. Now I need to do some reverse engineering. I want to figure out how many people use just Facebook. That's the yellow part that doesn't overlap with the blue. So if I scroll up a little bit, it says 96% of US, not 96, 69% of US adults use Facebook. That's the whole circle. How do I figure out the part of the circle that's not overlapping with the blue? Subtract, yeah, 69 minus 32, which is 37, yeah. Filling out the blue section is the same. If I just want Instagram users, I take the, where is it, 40% that represents the whole circle, and I subtract off the 32% overlap, and I get 8%. I should label the white space that represents people who don't use either. How do I figure that out? We add, and we did that in the last problem. We know that this represents 77% altogether. Very good. The whole box has to be 100. 100 minus 77 is 23. So 23% of US adults don't use either Facebook or Instagram. For example, my parents, who don't know how to use their cell phone, let alone social media. Once it's all sorted like that, I can answer all sorts of probability questions about how users of Facebook and Instagram relate to each other without having to do lots of complicated rules or remember anything, because I'm then just picking numbers out of a picture that match the area that I'm interested in. Okay, so what we're going to do, we're going to look at some vocab. We're going to practice drawing these pictures and using them to answer questions. So, real quick vocab rules. First, we're going to start with a complement. The complement of event A is everything that's not A. And we know we write that as A, and then a C as a superscript. Looks kind of like an exponent. That means the complement of A, which is everything that's not A. Everything that's not A. So looking in this Venn diagram, which section of the Venn diagram represents not A? The outside of the circle. Very good. So all of this here is my not A. And you will notice there are highlighters at your table for a reason. Highlighters are going to be your best friend when working with Venn diagrams. If you're working with your own markers or highlighters, colors that overlap to produce a new unique color, like yellow and blue make green, are helpful, because then it's really easy to identify the overlap because it changes to a new color. Okay, let's try another one. Next new notation is the intersection of two events. Intersection. Intersection represents A and B. That sounds healthy. Oops. And we represent the intersection with what looks like an upside down U. And you probably saw this in Math 3 when you were talking about domain and range sets and all that kind of fun stuff. So this stands for intersection. And the intersection represents the overlap between A and B. In that picture, where do A and B overlap? In the middle. So A intersect B is this section right here. That would have been the 32% in our last question. 32% of users who use both. Good. Next one is our intersection. Or not our intersection, we just did intersection. Our union. Union represents or. I could be A, I could be B, I could be both. Or gets represented with what looks like a U between the two symbols. And a union joins the two sections together. And you probably saw that when you were talking about domain and range, because we typically were joining sections that were separated by like an asymptote when we talked about domain in Math 3. So let's shade that in. What am I shading in for the union of A and B in that picture? A and B, both circles, right? So all of this gets shaded in. It's just everything inside the circles. Yes. We're going to do an example. Before we do the example, a word of warning. I would strongly recommend drawing a little Venn diagram and shading in areas when you're asked questions like this. So if you see a two-way table with 2 columns and 2 rows, Venn diagrams are really helpful. All right, here we go. Last example. In our statistics class, you are interested in exploring the taste preference of your classmates. You have 2 tastes, sweet and salty. 25 students were asked if they prefer both, only sweet, only salty, or neither. The following two-way table shows the data. Let A equal sweet, B equal salty. Draw a Venn diagram and find and interpret the following probabilities. So, first thing they ask us to do is draw a Venn diagram. So we know Venn diagram is a big box that represents our population or our sample space. In this case, what is my sample space? The what? Who are we interviewing for sweet and salty? The 25 students in an AP Stats class. Good. So that box represents all 25 students in my AP Stats class, which is the size of my second period because it is teeny compared to you guys. You'll notice I haven't drawn circles for sweet and salty yet because before I draw the circles, I need to know if the circles overlap or are separate. Are A and B mutually exclusive? So take a second, check in with your neighbors, and then we're going to vote with our thumbs. Maybe at 30 seconds. Mutually exclusive or not? All right, we're going to vote with our thumbs. If they are mutually exclusive, you're going to give me a thumbs up. If they are not mutually exclusive, you're going to give me a thumbs down. I want to see thumbs in 3, 2, 1. Show me your thumbs. Majority are thumbs down. Very good. So if it's thumbs down, not mutually exclusive, that means there's overlap. How many people in my class like both? 6. Very good. 6 people in the overlap. So I know my circles should have an intersection in the middle. Or ovals in my case because I can't draw. I'm going to label those circles A and B. And you can put frequencies in these tables or these boxes. I prefer to put percents or decimals in there because I'm going to answer probability questions, which should be percent or decimal. If I want to convert these numbers in the table into percents, how would I do it? Very good. Why multiply by 4? Very good, Janan. Yeah. So we know that to convert this to a percent, we divide by the total, which is 25. 25 times 4 is 100. So if I multiply those numbers by 4, it's turning it to something out of 100, which is a percent. So you could divide and then multiply by 100, or you could just multiply by 4 because we're lazy. So 6 times 4 is 24. So I know that overlap is 24%. 6 times 100 divided by 25, 100 divided by 25 is 4. So we're just multiplying by 4. Good. Next section. A is sweet. I want the number of people who said yes, sweet, no, salty. 11 times 4 would be 44%. Lots of people like sweet. Next section, I want the people who said yes, salty, no, sweet. 7 times 4 would be 28. I'm assuming I can do math in my head. Stop talking about hash browns. You're making me hungry. The section outside the circles, what does that represent? The rest, which are people who do what? Neither. No salty, no sweet. So in that table, that's one person. So 4%. Very good. We can now use that picture to answer questions about probability regarding salty and sweet preference in our class. So first probability says PA intersect B. A intersect B. Where does A intersect B in that picture? 24%. Very good. We know the intersection is right here. Actually, let's do this. Nice and straightforward. Happy face. Okay, next one. I want A union B. Where is A union B? The whole both circles, yeah. So A union B is all of this, which would be 44% plus 24% plus 28%. 68, 78, 88, 96, yeah. I could have. But doing mental math is good for my brain. Keeps it working while I'm old. Good. All right, next two. I'm going to draw a new Venn diagram just so we have something to shade in. All right, next one says PA intersect BC. So A intersect not B. So I'm going to do two colors. I'm going to do A in yellow. I'm going to do not B in blue. And I know intersect is the place where they overlap. So we'll start with A. A is just a circle that's labeled A. That's pretty straightforward. A is just this. Where is not B? Outside of what? Not B is everything that's not B, which is everything outside of B. So yes, it's the white space. It's also the part of A that is outside of B. Where do I see an overlap of two colors? The 44. The overlap of both colors is just the 44. Intersection is where those two things overlap, meaning they colored them in with both the yellow and the blue. Which percentage got colored in with both colors? 44. An intersection is where both colors sit. A union is anything that got colored in. We're going to do one more. I'm going to draw another Venn diagram for us. wrong pen. Okay. Last probability. Is P not A union B? Not A union B. Same process. I'm going to color in the first one in yellow. I'm going to color in the second one in blue. Where is not A? Ooh. Outside of A, yeah. Good. So everything that's outside of circle A. Everything here. Everything, oh, here too. Everything outside of A. Check mark for the first color. Next one is B. All of B. Okay. This is a union. Union means everywhere that I colored in. Everything that got a color. So which sections got color? So 4 plus 28 plus 8. So 36, that's going to be 4 plus 20. Oh, this should be 24. You're right. Sorry. Oh, I did. Thank you. I thought that looked a little weird. So 66%, which is also 100 minus the 44%. That was the only thing that didn't get colored in. Yeah, very good. Perfect. Good. So things to remember when you're doing unions and intersections. Intersection is the part that got both colors. Union is anything that got colored. Yeah? Use Venn diagrams liberally with probability questions on your scratch paper. It's a great way to visualize for people like me who like pictures to make sense of things. Yeah? Good. Questions on Venn diagrams or addition rule? No. All right. I'm going to pass back your Unit 2 tests, which I finally graded. While I'm doing that, you have the rest of the period to work. Yeah? If you have questions, let me know.